Good morning. Now we are going to see the characteristics of Zener diode. Before going to see this experiment, we have to know the component, which one is the Zener diode. Here, the black color which is shown, this is the PN junction diode. So this diode is how we are differentiated. The positive terminal, negative terminal is the negative terminal. It is a white ring color, that is the negative one, and the remaining one is the positive. When we have to differentiate the PN junction diode with the Zener diode looks like, which is orange in color and smaller in size. The terminal, how we have to differentiate the positive terminal, negative terminal is the positive will be plain and the negative will be in a black color band. So this is how we have to differentiate the diode. So we have chosen the diode. With the help of this diode, we are going to see the connections, and we are going to see the experiments. Before going to the experiment, we are going to see the parameters, and this is the regulated power supply or PS, and the ammeter, voltmeter, and this is one is the Zener diode, and we are using the resistors and breadboard, and with the help of this all this connecting wires, we are connecting this. Here, with the help of the circuit diagram, we have two circuit diagrams. One is in forward bias and another one is the reverse bias. The difference between this is the diode, the Zener diode, which is the positive terminal is connected and the negative terminal is connected in forward bias across the voltmeter and the regulated power supply. And in reverse bias, the polarity should be changed. The negative terminal should be connected to the ammeter negative, and the positive is connected to the negative of the RPS. Likewise, we have to give the connections. With the help of this circuit diagram, we are giving the connections. Here, this is the regulator's power supply. The positive terminal is connected to the resistor positive, and the negative terminal and the negative of this resistor is connected to the ammeter positive, and the negative of the ammeter is given to the Zener diode. Before that, we have to connect this Zener diode. We know that it is positive terminal and the banded one is the negative terminal, and that is given to the circuit. Here, the positive terminal and negative terminal is connected. It is given in the circuit, right? So this negative terminal of this ammeter is given to the positive of the Zener diode, and the negative of the Zener diode is connected across the RPS regulated power supply. Likewise, in the circuit diagram, the connections are given. Now we are going to start the experiment. We have to switch on the supply. We have to minimize this voltage. So initially the voltage is 0 and the corresponding ammeter and voltages ratings are 0. We have to increase this voltage level to 1. The corresponding voltmeter and ammeter reading is noted. So it is lightly varying as 0. It is moving from 0, right? And corresponding voltmeter reader, here the voltage is also 0. We have to move to the point 3. See, here the value is 0.01, right? So it is 0.01, and the corresponding voltmeter is also varied from 0 to some other 0.1 point. Likewise, we have to vary the voltages in the regulator power supply. The corresponding voltmeter and ammeter reading are noted for forward bias. So we can see the other set of values, that is we have kept as 4. The corresponding ammeter and voltmeter readings are noted. Here it is 0.1 and it is 0.01. So similarly, we have to increase the voltages. It is RPS, it is 5, and the corresponding ammeter and voltmeter readings are noted. This is for forward bias. When you are coming for reverse bias, we have to minimize this voltage. We have to switch off the power supply. Then we have to take this Zener diode and we have to reverse it, that is we have to change the polarity, and just we are inversing this Zener diode and giving to the circuit. Right. So we inserted by changing the polarity. It is noted that, see, it is very clear, the black color, that is negative term, is given to the positive of this voltmeter and the positive is given to this negative of the RPS, right? Similarly, we have to switch on the supply. Initially the voltage will be 0. We have to increase this voltage to the corresponding, just we can set it as a 4, right? We have set it here, it is a 3. The corresponding current rating and voltmeter rating is noted. So it is 0.01 and it is 0.1. And we have to increase the voltage to the 5. So the corresponding voltage is that is the current rating is 0.2. The ammeter rating, the voltmeter rating is 0.4. then we have to increase it. It is the voltage is 6 and the corresponding ammeter and voltmeter. Likewise, we have to increase the voltages and corresponding ammeter and voltmeter reading is noted. And this is the set of values as here we noted here. In reverse bias, we can note that the constant voltage after 5, we are increasing the voltage in the regulator supply, the voltage level is maintaining at a constant level. Likewise, we can get the characteristic curve of PN junction. In forward bias, it is gradually increasing, and we are coming for the negative, that is a reverse bias. The voltage is constant and the value is very constant, so it is a straight line and we get the values. This is the reverse bias of a Zener diode. Thank you.